I'm going to re-explain that. Okay, multiplying polynomials. So when you're distributing with letters and exponents, our rule is to add the exponents. So 5 times 2 is 10. X times x cubed is x to the fourth, because 1 plus 3 is 4. Yes? Okay, so then again, I keep going. 5x times 6. Well, what's 5 times 6? Positive 30. And there was only one x being multiplied, so it's just x. Now, can those combine?
Nope.
No, they're not like terms. So that is my answer. Okay, so when I do this one, I have negative 3x squared times 5x squared. Well, what's negative 3 times 5?
15.
Negative 15. And then x squared times x squared. X to the fourth power. Okay, so then I keep going. Negative 3x squared times 6x. Well, negative 3 times 6 is negative 18. X squared times x is x cubed. And then lastly, negative 3x squared times negative 1. Well, two negatives makes a positive, and that gives me 3x squared times 1, which is just 3x squared. I don't think the door has ever been knocked down as many times all year in one period. Okay, any questions with those when we're distributing a monomial? So we're just distributing. Multiply your coefficients, add your exponents, yes? Okay, so now we have binomial times binomial. Binomial times binomial. So y'all might have heard FOIL. Do y'all remember hearing FOIL? First, outer, inner, last. Okay, I just call it double distribution because we're used to distributing. We're just going to do it twice now. So you have an x put in a plus 1, and then you have the x minus 3. So we're going to start with the x, and I'm going to distribute to the second set of parentheses. What's x times x?
2x. 2x.
X squared. Okay, and then what's x times negative 3? Negative 3x. And now this is where the double distribution comes in. So the second one, I'm going to distribute the 1 now. What's 1 times x? Just 1x or x, either way. And then 1 times negative 3? Negative 3. Can that be simplified? Yes, you will almost always, not always, almost always be able to combine the middle two terms whenever you have a binomial times a binomial. So my first term does not have a like term. What's negative 3 plus 1? So I have negative 2x, and then bring down our minus 3 that doesn't have a like term. Okay, so I want y'all to try example 4 really fast while I take attendance. Okay, so what do I get with the first? 6x squared. And then what? Minus 15 what? X. So plus 4x minus 10. And what two terms can we combine? The middle two. And what does that give me? Perfect. Okay, so the next two are very, very, very similar, except they have like special names, and this will make a lot more sense when we're factoring, which is going backwards, but today it's fine. So this one, what do we notice? It's squared, so we call this a perfect square because it's the same thing times the same thing. However, with the rules we learned with Power to a power. You can't do that here because there's a minus in the middle. So you can't just give the squared to both terms and call it a day. You have to actually write it twice and double distribute. Okay? So what's 2x times 2x? 4x what? Squared. 2x times negative y. Well, this is the same thing as saying negative 1y. So what's 2 times negative 1? Negative 2. And then you have an x and a y, which aren't alike, so they just go next door to each other. So same concept. This is negative 1. So negative 1 times 2x. Negative 1 times 2 is negative 2. Yx, always write them alphabetical, so it's xy. And then last but not least, negative 1y times negative 1y, which is the same as just negative y times negative y. Two negatives makes a, and then we get y squared. Is it okay if you put the 1 in front? Yes. What are my like terms? The middle. And what does that give me when I combine them? Not 0. Two negatives don't cancel. Negative 4xy. Now with perfect squares, you'll notice that the first term and the last term are a perfect square because 2x times 2x is 4x squared and y times y is y squared. The middle term we'll talk more about when we're factoring, but there's a way to find that as well to prove that it's a perfect square. Now what do you notice about example 6? They're the same except
They can cancel each other out.
kind of the sign. One's minus and one's plus. So we call this difference of squares. And you'll see why when we get our answer. Okay, so we're going to distribute. What's 2x times 2x? 4x squared. And 2x times 1? Which is positive 2x. Negative 1 times 2x. And negative 1 times 1. What do you notice now? They do cancel. A positive 2x and a negative 2x make a 0 pair, which means they zero out. So I'm only left with 4x squared minus 1. Now we call this difference of squares because what does difference mean? This will be subtraction every time. And of squares, well 2x times 2x is 4x squared and 1 times 1 is 1, so they're both perfect squares. Yes? So it's the difference of two squares. Okay, so those are those. Okay, and then lastly we're throwing some trinomials in there. We're going to do a binomial times a trinomial and a trinomial times a trinomial. However, I want to show you kind of how to make them a little easier when it comes to combining like terms versus having that really long line of just a bunch that you're trying to find them all. So I'm going to show you. So again, we're going to start just like we did on all the others. We have two things to distribute in that first set of parentheses, so we're going to distribute them both.
Did you go t first?
So t times 3t squared is just 3t cubed. T times negative 4t is negative 4t squared. And t times 2 is just 2t. Are we okay with that first distribution? So I had 3 terms to distribute it to, so I had to distribute it to all 3 terms. So now I still have the 2. Well, what's 2 times 3t squared?
6.
So I'm going to put it right here, 6t squared. Why do you think I put it right there? I lined it up with its like term. Now, is it a positive 6 or a negative 6?
Positive 6.
Okay. And what's 2 times negative 4t? Negative 18. Look where it lined up with its like term. And what's 2 times 2?
4.
And now it's easier to find our like terms. Well, did the cubed have a like term? No. What's negative 4 plus 6?
2.
And what's 2 minus 8? and bring down the plus 4 that also did not have a like term. And there's your answer. Okay, last one. We're going to start the exact same way, except this time we have a trinomial times a trinomial. So instead of just 2 sets of arrows, I'm going to have 3 sets of arrows. So what's 2x squared times x squared? 2x not cubed to the 4th. 2x squared times 5x. 2 times 5 is 10. X squared times x is x cubed. And then 2x squared times negative 2 is negative 4x squared. So now we have the negative 3x times x squared.
Negative 3x cubed?
Negative 3x cubed, so I'm going to line it up with the cubed. Negative 3x times 5x.
Chain x cubed, squared.
And then negative 3x times negative 2. Positive 6x. 2 negatives makes a positive, yes? Everybody okay with this so far? Okay, one more term to distribute is my 4. What's 4 times x squared?
4x squared.
So I'm going to line it up with my x squareds. It's positive 4x squared. And what's 4 times 5x?
20x.
And lastly, 4 times negative 2.
Negative 8.
And we're going to bring down this first term because there's no like term lined up. What's 10 minus 3? So I have 7x cubed. Now, there's 2 ways to do this one. You could type negative 4 minus 15 plus 4 in your calculator, or do you notice that the 4's cancel? Because they're a 0 pair, so I'm left with negative 15x squared. And what's 6 plus 20? And then the negative 8 had no like term.